Hey guys, this is Mr. Gron with a video on linear functions review for the linear functions quiz in Algebra 2. How you should use this video: pause the video when you see the question, try it on your own, and then unpause when you're ready to see the answer. All right, so the first one here, we've got a number line graphing this, couple things. It is x greater than 3. It's not the greater than or equal to, or negative 3 I should say. And so negative 3 gets an open circle. Now I have to determine which way to shade. X is greater than, right? The crocodile eats the bigger one, and so we're shading to the greater than side. Also, if we rewrite this sometimes, we've got negative 3 here. If I switch this around so that the alligator is always pointing to the right, that kind of shows me which direction x is going to be if I rewrite this underneath. And so I can shade to the greater than side. All right, graphing x equals 3. So with this, x equals is always a vertical line. Y equals is always a horizontal line, and sometimes students get those mixed up. The reason for that is if I just start plotting some points where x is equal to 3, so maybe this point right here, that's at 3, 0. Maybe another point is up here at 3, 5. Maybe another point is down here at positive 3, negative 8, right? These are all points that have x. Their x values equal 3. So all of the points along this vertical line have an x value of 3. So that is your line x equals 3. All right, so for this one, remember the purple area, this is the solution set, right? The blue area is everything above this line. The red area is everything kind of below and to the right of this line, and their intersection, blue and red, make purple. All right, so graph is a little blurry, so I added some tick marks on there. 2, 1 would be right about here, and so point A, that is a yes. Negative 1, 4 would be right about here for point B. Now that's in one solution set, but not the solution set of both. So this one is a no. It's got to be in that intersection. C is 5, 0, so that's going to be over here. That is a yes. It's in the purple. And then D, 0, 0. This is a tricky one. It depends on whether or not, because it's on the lines, right? If this were a solid line, it would be a yes, but these are dotted lines, which means any points on that line are not part of the solution set, so this one is a no. All right, line of best fit. We're going to need our calculator for that one. Okay, so if we fire up the old calculator, hit the Stat button, which is kind of top center, then the Edit menu, so the first option. Now if you've got numbers in there already, move up to where it says L2. Now yours will look a little different than mine, but it's mostly the same. And then hit the Clear button. Don't hit Delete, hit Clear and Enter, and that will clear out your lists. All right, so now the top one goes in L1. Those are your x values. So 2, enter, 3, enter, 4, enter, 6, enter, 9, enter. Then we'll scroll over to L2, and that's where the bottom row goes. Our y values, 122, 182, 240, 368, and 538. All right, so we've got our list entered. Now we go back to the Stat. Hit the Stat button again, scroll to the right to the Calc menu, and you want to go down to where it says Linear Regression, or LinReg, so the fifth option. And depending on yours, you should just have to hit Enter a few times maybe, and you should get something that looks like this. It might have a little more information than mine, but this is the stuff that you need, just the A and B values. So what do we do with those A and B values? We just plug them in. Y equals, we'll change the A to 59 point, I'm going to do 2 decimal places, 74. x plus the b value, 3.25, like that. All right, how many can they type in 1 hour using that model? All right, so what we're going to do, we're going to take that same equation and we're just going to plug in 60 because 60 minutes is 1 hour. So this will be 59.74 times 60 plus 3.25. And we'll round to the nearest word, so we'll say 3,588. All right, graphing this. For this one, I'm going to set up a table to graph this. There's a couple of ways that you could graph it. I'm going to show both of them in this. So what we really want to do first with an inequality is we want to treat it as if it were just y equals negative 3x plus 4. And I'm going to make a table with 3 values in it. Let's see. So for my table, I'm going to use negative 2, 0, and positive 2. I think that'll give me a nice little spread here. Okay, so for negative 2, it's y equals negative 3 times negative 2 plus 4, and that equals positive 6 plus 4 is 10. So at negative 2, our y value is 10. That's 1 point I can plot, and that's going to be all the way up here, right? Negative 2 horizontally and up 10. Then for 0, negative 3 times 0 plus 4, that is 0 plus 4 is 4, and that's the y-intercept. So some of you maybe just plotted that one automatically. So 0 left and right and just up 4 in the center. And then positive 2, negative 3 times 2 plus 4, that makes negative 6 plus 4, which is negative 2. And so 2, negative 2, that would be right about here, right? 2 to the right, and then down 2. And now I've got some points that I can trace a nice line through. Now, this is an inequality, so I have to think, should I have a solid line or a dashed line? And in this case, because it's greater than or equal to, I can have a solid line. Then the shading, y is greater than, that means above. So it's more left, or I mean more right than above, but this is still above it, right? If I thought about this point right here, up from that point is up in this half, right? It's not down here. The other way we could do that is pick a point. Maybe we pick 0, 0, the origin. That's usually a nice point. Is 0 greater than or equal to negative 3 times 0 plus 4? That would simplify to 0 greater than or equal to positive 4, which is not true, so it's not true at the origin. That means the other half is true. All right, graphing this one. I'm going to do a table again for this. So x, y, and I think negative 2, 0, and 2 are going to be pretty safe numbers to do. All right, so y equals negative 2 times another negative 2 plus 4. That is 4 plus 4, which is 8. So y is equal to 8. That means our point is up here, right? Because it's 2 to the left for the negative 2 and then up 8 for the positive 8. Then y equals negative 2 times 0 plus 4. That gives us 0 plus 4 is 4. So another one where the y-intercept is 4, and so you maybe just kind of started there. And then y, oh yeah, so that's 4. Negative 2 times positive 2 plus 4, that's negative 4 plus 4 is 0. So 2, 0, our x-intercept is right there. And now we've got 3 nice points that we can plot a line through. Throw some arrows on the end of it, and boom, you're done. All right, now this one I'm going to do a little bit different. I'm going to use the slope and the intercept to solve this one. Now to do that, I'm first going to convert this into slope-intercept form. You could certainly make a table with this. There are other tricks to this, but just for the sake of time, we're just going to do it this way. All right, so I'm going to move the 3x over by subtracting it from both sides, and that gives me negative 2y equals negative 3x plus 6. Now I'm going to get rid of the negative 2 by dividing it on both sides. And remember, when you're dividing both sides, you're dividing everything on both sides. So it's negative 3 over negative 2. That makes a positive 3 over 2x. And then the positive 6 divided by 2, that makes a negative 3 or a minus 3. Okay, so for this one, I'm going to use the slope, which is rise over run, right? And I'm going to use the y-intercept, negative 3. So I'm going to start by plotting negative 3. So from the origin, go 3 down, right there. And then now I'm going to count up 3 and over 2, my rise and my run. And that's going to be my next point. And I can just sort of make some steps that way. Up 3 over 2, up 3 over 2, up 3 over 2. And if I want to keep it going the other direction, right, it'd be back 3, down 2. Right? I don't want the stairs to start going the other direction suddenly. Like, they should all be nice and even. Make a nice staircase. And then I can put a nice straight line through there, and boom. All right, what is the slope between these 2 points? We need to use the slope formula. y2 minus y1 over x2 minus x1. Remember that your y values are the vertical components, so the difference between them is the rise, and the x coordinates are the horizontal components, so the difference between them is your run. Okay, in this, remember that these are xy coordinates, right? So this is x1, y1, x2, y2. Sometimes students put x1, x2, and y1, y2, but each one is its own xy coordinate. And now I can just plug things in from there. That would make it 6 minus 9 over 2 minus a negative 1. Remember, minus a negative makes it a plus. And that makes this negative 3 over positive 3, which would reduce to negative 1. All right, now the equation that passes through those 2 lines. We already figured out what the slope was, right? That was negative 1. Now we want to use the point slope form. Now I need to choose one of these points to use. I'm going to choose the 2, 6, just because they're both positive, and so I think that's a little easier to work with. Oops. And now this is going to be y minus y1 is equal to m times x minus x1. And we're just going to plug things in. Y minus 6 is negative 1 times x minus 2. And now this might be good enough, but you might have to simplify it into slope-intercept form. And so if you have to do that, we want to start by distributing the negative 1 into the parentheses. So we get y minus 6 equals negative x plus 2. And then now we want to solve it for y on the other side, so I'm going to add 6 to both sides so that it's y equals. So y equals negative x plus 8. All right, what slope is perpendicular to this? So if m, our slope, is equal to negative 2, remember that's the same as negative 2 over 1. Perpendicular slope is opposite reciprocal. So the perpendicular slope is equal to, it's going to change to positive from negative to positive, and then the fraction is going to flip, so positive 1/2. And you don't have to label it like this. I just like to do that. All right, an equation of a line that passes through this point and is perpendicular to the second, or to the line there. So the first thing is I need to know what my perpendicular slope is, right? The slope here is 1/2, so my perpendicular slope is going to be, it's going to change to positive, and it's going to be 2/1 instead of 1/2. And we can change that to just positive 2. All right. Slope-intercept form, or point-slope form, I need an x1 and a y1, so those are those two. And now, again, I am just plugging it in to my point-slope formula. So y minus a -5 is equal to 2 times x minus a -3. Remember, subtracting negatives, that changes it to a plus. Maybe that's good enough. Maybe you have to do slope-intercept form, so let's practice that. So 2x plus 6, and now we just subtract 5 from both sides. And that's going to give us y equals 2x plus 1. Solving and graphing. Okay, so solving a one variable inequality and then graphing. Remember PEMDAS stuff. I'm breaking this down to try to get P all by itself on one side. The outermost layer from that is that -3, right? I got to get rid of that first. So the first thing I'm going to do is divide both sides by -3. Now, that gets me to P plus 1. I don't need the parentheses anymore if there's nothing outside of them. -18 divided by -3 is positive 6. And now the only thing left to get rid of is this plus 1, which is not, don't get rid of it by subtracting 3. Get rid of it by subtracting 1. And we get that P is less than or equal to positive 5. So on my number line, I got to adjust it here. Add a 5 down here. First thing is, do we have a solid or an open dot, right? If it's less than or equal to, that is solid. Now, if I think about where is the less than side, if I rewrite this down here, the alligator is eating to the right, so it's in sort of the correct orientation, and that puts P to the left, and so I will shade to the left. All right, last one, graphing this inequality. For this, I'm going to start it out by converting this into slope-intercept form, and I'm going to make it an equation. Okay, so first thing I want to do, I'm trying to solve it for y. What's the furthest thing from y is that 3x. Let's get rid of that. -4y equals -3x plus 12. Now the only thing left is this -4. I can get rid of a times -4 by dividing both sides by -4. And that gives me y equals -3 over -4 for the x is positive 3 over 4x. And then the plus 12 divided by -4 makes a -3. Now I'm going to do slope-intercept again for this one. The slope, the rise over run, is 3 over 4, and the y-intercept is -3. So if I plot the -3 first, is right there. And then if I start making my steps, they're going to go up 3 and over, up 3 and over 4. Up 3 over 4. And if I want to make some more steps behind, I can kind of do the opposite as I'm going right to left instead of left to right. Okay, now the line, it is, if I go back to my inequality, it is not, it's a greater than symbol, not a greater than or equal to, so this needs to be a dashed line. And now I have to think about where I want to shade. With this one, I would plug back in. I wouldn't try to think of like if this is greater than and the equations on that side that it should be top or bottom. I want to plug in and figure this out. And the easiest point to plug in is always the origin, 0, 0, right? What's happening there? 3 times 0 minus 4 times 0, is that greater than 12? Well, 3 times 0 minus 4 times 0 is 0. Everything cancels out. So is 0 greater than 12? And the answer is no, that's not correct. So it doesn't get shaded at the origin. That means it gets shaded on the other side. So it's not shaded above in this case, it's shaded below. All right, that's it. Email your teachers if you have any questions, and have a great day.